Select the best set of reaction conditions to accomplish the following transformation. So we want to identify what type of reaction this is. So we can see that we are starting with a diol and that we are forming a molecule that has a ketone and a carboxylic acid. So we are oxidizing the two alcohols from the diol to these two carbonyl compounds. So this is an oxidation. So we know several conditions to oxidize alcohols. So in order to select which one we are actually using, we need to look at our alcohols and we need to look at the products. So we see we have a secondary alcohol. So that is an alcohol on a carbon that has bonds to two carbon atoms. And then the other alcohol, we see that that is a primary alcohol. So that's an alcohol on a carbon that has a bond to only one carbon atom. So when we're deciding between oxidation conditions, we want to pay attention to the primary alcohol. Primary alcohols can be oxidized to give us aldehydes, and they can be oxidized even further to carboxylic acids. And so we see that this primary alcohol is being oxidized to a carboxylic acid in this case. So that means we need a strong oxidizing agent. And so the strong oxidizing agent that we've been introduced to that does this reaction is chromic acid. And chromic acid can be formed by mixing together chromium trioxide and aqueous acid and acetone. So this is the set of conditions that we want to use. And so we know that by looking at what's happening to the primary alcohol. The secondary alcohol will always be oxidized to a ketone. And so we do have a couple other oxidizing agents here that I want to mention. So A and C would also do an oxidation. Either one of those would oxidize the secondary alcohol to the ketone, but they are more mild conditions. And the primary alcohol, if we used either the PCC, that's the pyridinium chlorochromate, and a non-aqueous solvent, that would oxidize a primary alcohol to an aldehyde. And the second set of conditions here, we have dimethyl sulfoxide, oxalochloride, and triethylamine at a low temperature. This is known as the Swern oxidation. So either one of those two conditions, the PCC and the dichloromethane, or the Swern oxidation, or we've also seen oxidations with hypochlorous acid. Those are all mild oxidizing agents that would take the primary alcohol to the aldehyde. So the stronger oxidizing agent, the chromic acid, would form the carboxylic acid.